G'day, we're going to look at different types of circuits that you can make. You've possibly already made these when you've been messing around with some of the electrical equipment in the science lab, but what exactly have you made? So there's a couple of types of circuits you can put together. They can be sort of a mixture of each, but there are two basic types. We've got what's called a series circuit, where components are connected one after the other, and a parallel circuit, where you've got things sort of side by side. Look at the wires connecting the two light bulbs there, and it's actually easier to see when we draw it as using the circuit symbols, so we'll get into that. So a series circuit, there it goes there as the picture. They're connected end to end, one after the other. So one component after the other, around the circuit it goes. A simple loop, current can just flow around it and keep on going around, unless something breaks in the circuit. We break the wire, we break a bulb, then the whole lot goes out. Because if one of these bulbs is broken, so let's say this one here is dead, the current cannot get past that point. It can't go any further. It's stopped there. So in a parallel circuit, we've got a choice of pathways. They're connected side by side. So it's possibly clearer to see in the circuit symbol diagram there. The current's got a choice of places it can go. So it's coming out of the battery and it can go into there, or it could go into there. It can go either way. So if one of those bulbs blows, so let's say this one dies, this current stops, but we've still got it flowing through here. We've still got a light on. And this is how houses are wired up. Your lighting circuit in your house is done in parallel, so if one bulb pops, the rest keep going. You're not left in the dark. So let's look at measuring the current that's flowing around your circuit. We measure that in amps, and we're using an ammeter to measure that. So that's what an ammeter could look like. Numbers on the dial there, and that's the circuit symbol for ammeter. Just a capital A in a circle. And we stick that in the series circuit in series. It's connected in series, it's plugged into the circuit, so it's measuring how the current is just flowing through it. We could put it over here, the same thing, or we could put it there. The current's got to flow through it, and we just measure how fast it's going past. Parallel circuit, same deal. We could put it there, we could put it over here, we could put it in here, we could put it into here, as long as it's put into the circuit in series. So what is it actually measuring in those places? Series circuit, the current is the same everywhere. So wherever we are, the current's the same. It's only got one circuit to flow around, so it's the same current everywhere. Parallel circuit, however, the current gets shared out. So I've got 2 amps of current here. I've got 2 pathways for the current to go through. It's shared equally between those pathways. Now, if this was 3 amps, I'd have 1.5 here and 1.5 here. Okay. If it was 3 amps again, but I had an extra pathway, does a bit roughly, make sure it connects, the light bulb, then I'd have 1 amp, 1 amp, and 1 amp. So whatever current I have, it's shared out equally between the components in a parallel circuit. Let's look at voltage. It's a little bit different. This is how much energy the electrons are carrying around the circuit. So voltmeter looks very similar to an ammeter. There's the symbol, capital V, and it's a little bit different when we put this into the circuit. So more voltage, we're going to see that in the current carrying it around. It's connected across the components, so the voltmeter is connected in parallel across the components. We're sort of going to measure the energy before and after the component. Sometimes we call that the potential difference between before and after a component. So what does that look like? So let's draw it. Series circuit, there's our voltmeter, it's across the light bulb. We could add another one in. We could put one here across the cell. We could put one across this here. It's always got to be across the component. There'll be no point in putting it across here. There's nothing to measure there. It needs to be across the component, so that one's no good. What about a parallel circuit? So once again, across the components, same thing. We could have it across here. We could have another one in across here as well. Oops, put the V into that. It's a bit rough and untidy. But measuring across the components. So what numbers do we get out of that? Series circuit, the voltage is shared between any of the components. So the battery is giving out 3 volts. That's all the energy that's going to be in the system. So however many components I have, it's got to be shared out. If I had a third bulb here that was equal sized, I'd have 1 volt there, 1 volt there, and 1 volt there. It's shared equally. So whatever is given to the system is shared out equally across the system. Parallel circuit, however, the voltage is the same everywhere, because we've got a number of different pathways to go. So 3 volts is given to the system. That 3 volts can go through this pathway, or it could go through this pathway. If this pathway is blocked off, there's still 3 volts going through here. Now this means these bulbs are glowing equal brightness, whereas in the series circuit, because of the energy is being shared out, the bulbs, as they add more bulbs in, they get dimmer and dimmer. This is another reason why houses are wired up in parallel. So each bulb gets the full dose of energy, and if one bulb blows, you're not left sitting in the dark. So let's summarize all that. Series circuit, parallel circuits. Here they are connected end to end, a continual loop. Here they are, they've got a choice of pathways. The current is the same at all points in a series circuit. The current is shared out between components in a parallel circuit. Voltage is shared in a series circuit, but it's the same everywhere in a parallel circuit. That's what an ammeter looks like, and it's measuring how fast the current's flowing past a particular point. That's what a voltmeter looks like, and the voltage is how much energy is given to the electrons carrying the current, or the current flowing around the circuit. And I've just noticed that my voltage symbol is upside down there. Apologies for that. Make sure you draw it the right way around when you make your diagrams. Okay, so that's sort of a summary of series and parallel circuits, the 2 types of circuits you can create, and also talking about the current in those circuits and the energy or voltage in those circuits. Hope that's been helpful. If it's been a lot to soak up, go back, replay the video, absorb it again. I hope it's been helpful. Thanks for watching.